Hello there and welcome to a brand new lesson. This is Hack Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at quadratic functions. By the end of this lesson, you should be able to define a quadratic function and identify its standard form. You should be able to identify the role of the coefficient, that is A, B, and C, in determining the shape and the position of the parabola. You should be able to find the vertex and then axis of symmetry, the y-intercept and the x-intercept, which is called the roots of the quadratic function. And then you should be able to solve quadratic equations by factorization. And finally, you should be able to determine the number of real roots using the discriminant. Now, we have some key vocabularies here we'll be using as the lesson proceeds. So I advise you pause and quickly take a glance before we continue. So let's start by exploring what a quadratic function is. When we have a function f of x that is equal to, so first of all, we spoke of linear. So if f of x is equal to mx plus c, we said it is linear. For linear, we said the highest power is 1. M is the gradient, and then C is the y-intercept. But for quadratic, on the other hand, we say f of x, that is the function in terms of x, is ax squared plus bx and then plus c. This here is the standard form of a quadratic function. Now, a, just as in linear, m has a row it plays, and then c also has a row it plays. For quadratic as well, the a has a row it plays, the b has a row it plays, and the c also has a row it plays. First of all, the highest power of x in the quadratic is 2. You know, there is 1 here, and then there is 2 here. So anytime you have a function whose highest power of x is 2, it is a quadratic function. And you'd always take note that the a shouldn't be 0, because if the a becomes 0, then all this goes off and you are left with this, which then looks like what? A linear function. So the value of a can be positive and it can also be negative, but it should never be 0. Now the b over here shifts the axis of symmetry. I'll be giving you some diagrams to represent these quadratic functions, and you get to understand what we mean by it shifting the axis of symmetry. Just as for linear, we have where we call the y-intercept. For quadratic as well, there is the y-intercept, which is c. So if you want it as a coordinate, you know, for y-intercept, the value of x is always 0. So in terms of coordinate, the y-intercept is simply 0, c. So this is the standard form of a quadratic function. Now let's look at how the quadratic functions actually look like on a graph sheet or on the Cartesian plane. So with our Cartesian plane, remember in our previous lessons, we said for linear functions, they are just straight like this, right? So either straight like this or this way, depending on the gradient. But then for quadratic functions, we have 2 types that they can actually be represented in. We have it either being a U, looking like a U, you see, that is, it opens upward, or something like an N. So let me do that for you. So that is what you see over here. A quadratic function can either be like this you see over here, that is in a U form, or this you see here in the N form. Now this is a function of the a, you see. So in our quadratic function we have over here, this a is what accounts for the graph being a U-shaped or an N-shaped. When our a is greater than 0, we always get a U shape. So this is for a being greater than 0. On the other hand, if our a is less than 0, so if a is less than 0, we end up getting something like this. For a to be greater than 0, we mean if you take a quadratic function such as, let's say, 2x squared then minus 5x plus 3. For this here, you see our a is 2. 2 is greater than 0. It is a positive integer. So we simply mean if the a is a positive integer, we are always going to get something like this. But then if the a was negative, so let's say negative 2x squared minus 5x plus 3. This time around it is a negative. So we are going to get this we have over here. So mentally, without even drawing, you should always know the form your graph is going to take depending on the value of a. Now, with that said, these two graphs have unique features, you see, and that is the maximum and then the minimum value. So first of all, if we look at that for which a is greater than 0, it has, for each x value, it has corresponding y value. Now, as the y value descends, there's a point where it descends to its minimum and then moves up again. That is this point we see over here. We call this point the minimum value of the function. You see, so that only happens when our a is greater than 0, because the function does what? It decreases from the left hand side, so it decreases and then gets to the minimum value and then it now increases. For that which a is less than 0, on the other hand, starting from the right hand side, starting from the left hand side, the function increases. You see, so from negative 5, it increases all the way up toward 5, and that becomes its maximum value. You see, and then it now decreases. So for a is greater than 0, it opens upwards and forms a U and has a minimum value. We will look at how to actually get these values. Then we now have what? For a which is less than 0, the function increases to its maximum value and then it decreases. These are the unique features of these two. We then look at the key features of a quadratic function. Now, talking of these features, we will take this sample quadratic function here and we'll talk about all of this so that you really understand how to identify them. So let's start with what we call the y-intercept. When we talk of y-intercept, it is simply where the curve touches the y-axis. This is our y-axis, you see. So where the curve touches the y-axis, you see. So this is our y-axis over here. This particular place is the y-intercept, you see. And by looking at your function, you can easily tell. We said that is the value C. So if I'm to label this particular point, that is where our function touches the y-axis, it is going to be what? 0C. 0C, because at this particular point, the x-coordinate is what? 0. You see, so the x-coordinate is 0. Then it comes down toward my y that we have over here. And how do we actually get it? So you just set your x to be 0 and then find the function f of 0, and that always gives you a c. That is the first thing you should take note of in quadratic functions. That is the graphical one. The second thing you should take note of is what we call the axis of symmetry. When we say axis of symmetry, a body or a 2D object or whatever it is symmetrical if you can draw a straight line such that it produces two mirror images. Such that it produces two mirror images. So if we look at this over here, it is in a form of U. If I'm to draw a straight line through this point, that is through 1, you realize that I have formed two mirror images such that this side is the same as this side. Now to get this axis, which we call the axis of symmetry, it is simply x equals your negative b over 2a. Talking of x equals negative 2 bar. Talking of x equals negative b over 2a, where do we get it from? Remember the function, that is the quadratic function, f of x equals a squared, ax squared plus bx plus c. This is where we are getting it from. And how are we getting it? All we simply do is we pick our x and we say it is equal to whatever you have here as your b. You write it down as b over 2, then whatever you have here as your a comes here, but then you make it a negative. You see, we just negate it. So simply put, you take note of the value of your a and then the value of the b, and then you substitute it into this. Now you see why each and every coefficient or constant in the quadratic function is necessary. Because for c helped us to get what? Y-intercept. Then now a and then b are helping us to get the axis of symmetry. That is the vertical line through which we are going to get two mirror images of the parabola. There are a lot of information we can get from this particular graph, that is the quadratic graph. The other interesting one is what we call the vertex. The vertex is simply the coordinate of the minimum or the maximum value. So if you are using a being greater than 0, then your vertex is going to be what? A minimum value. But if your a is less than 0, then your vertex is going to be a maximum value. Now, how do we get it? If you observe this axis of symmetry we had over here, you realize that the x coordinate here is simply the same that you are going to use for this. You see? So with that, we can get the x coordinate of our vertex. Now, if we have the x coordinate, what do we do to get our y coordinate? That is this particular one. How do we get the corresponding y coordinate? To get the corresponding y coordinate, all you do is, we know our function. Our function is in terms of x. So all you do is you substitute the x value. You see? So you substitute what you have as negative b over 2a. The answer you would get will be your corresponding value for what? Y. And as you know, coordinates are written as x, comma, y. So this becomes our x component. Then what you would evaluate becomes your y component. And that is going to be your vertex or the minimum or maximum value depending on the value of a. You see how simple it is? So we know how to get the y-intercept, that is simply c. We also know how to get the axis of symmetry, that is substituting our b and then a into this formula. And we also know how to get the vertex. So the vertex are in two folds, either a maximum or minimum, depending on the value of a. So you'd substitute this for your x, and then substitute your x into your function to get the corresponding value of y. The next thing we need to know is the x-intercepts. Now the x-intercept is simply also called the roots of your quadratic equation or function. When it comes to looking for the root, there are so many methods we'll be doing or working out in our subsequent lessons. We have the factorizing method, we have completing the square, and then we have the quadratic formula. We would be looking at order. Then you could also even do it graphically as well. So in order to solve for the root, all you do is you set your function f of x to be equal to 0. You are good to go. So as we proceed, we'll be looking at some of them. Now, knowing what the roots are, and then the three methods. For these three methods, we will look at one of them, that is the method of factorization in this lesson. So knowing what they are, depending on some criteria, the root or the nature of the root is affected. So now that we know what the roots are, we want to describe the nature of the root. Talking of the nature of the root, we want to know if the roots are the same, or they are different, or they are not even real numbers at all. You see, so to do that, we have what we call the discriminant. The discriminant is simply b squared minus 4ac. We would get to prove how all these come about, but not in this session. So with the discriminant, that is our b squared minus 4ac. There are three distinct values we need to know. First of all, if the discriminant is greater than 0, but before we look at that, the b, so we know our function is written as f of x. Let me clean this here. So we know for a quadratic function, it is written as f of x equals, we have a squared plus bx plus c. This is the quadratic function, the standard one. So to get the discriminant, we use the b. Whatever value you have here for the b, you take it and then you square it. Then minus a 4. This 4 here is a constant. So the value you have for the a, so for a, then whatever value you have for the c, you also take that and then put it here. This is what we call the discriminant, represented as delta. Now, anytime you evaluate your delta, that is, you evaluate the discriminant, and then you get its value to be greater than 0. That is, if you get a positive number, what it simply means is your function has two real roots. By real roots, we simply mean the line or your function touches the x-axis at two distinct points. So the points are this we have here, and then this particular one we have over here. They are two and they are distinct. Distinct means they are different. You see, that happens if and only if your delta is greater than 0. That is, after evaluating b squared minus 4ac, and then it is greater than 0. This is how your graph is going to look like. Secondly, if you evaluate your delta and get 0, then it simply means there is just one real root. So for such graphs, they are not like this. They are not drawn as this, but rather they look something like this. So they would actually be on the axis, you see. So with this I have here, if I'm to deepen it, you see, it is just touching your axis at one point. So it could be this or this as well. It can be anywhere, any quadrant at all, but then the most important thing is it should touch just one point on the x-axis. We are saying the degree is 2 and we are expecting 2 answers at the root. And the roots are simply where the function cuts your x-axis. But in this case, it is touching it just at one point. You see, so this is the point over here. That is, if you were expecting x1 and then x2, x1 is what? -3. That is for this. And then x2 is also -3. So there are two roots that are the same. The same applies here. So both x1 and then x2 are what? 4. So we say anytime we evaluate our discriminant and our delta is equal to 0. If it is equal to 0, then we have what? One repeated root. And this is how they actually look like. Their graphs don't touch this. They don't look like this, but rather they are on the x-axis. Now, there are those that do not even give us any real roots at all. So for such, if you evaluate your discriminant, you are always getting an answer that is less than 0. You are always getting an answer that is what? Less than 0. So for such graphs with these discriminants, they also don't look as you see this, but rather they are something like this. So this, you see, with this particular one, they don't even touch the x-axis at all. You see, so they lie somewhere that they try as much as possible not even to come close to the x-axis. You see, so they can be either u or v, any of them, but then they don't touch the x-axis. You see, anytime they touch the x-axis at 2 points, then they are going to be greater than 0, and they have 2 distinct roots. Anytime they touch the x-axis at just 1 point, then they are going to have what? Delta being equal to 0, and then there will be 1 repeated root. But for these particular ones, they don't even get close. They don't touch the x-axis at all. So their roots are imaginary numbers. You see, they are complex roots, or we call them no real roots. You see, so these are the quick or the key features of a quadratic function. So with all that we've done so far, we want to test our knowledge with some questions. So our first question we have here says, for f of x, which is equal to x squared minus 8x plus 12, find first of all the y-intercept. Secondly, we have to find the axis of symmetry. Then we have to find the vertex, and then there's a question that says, does the parabola open up or down? So let's go at the very first one. So we know f of x to be what? X squared, then minus 8x, and then plus 12. And the first one says we want the y-intercept. Now from our lesson, we learned what the y-intercept is. So for f of x, which is ax squared plus bx and then plus c, we said the y-intercept is always the constant c. You see, so the y-intercept is the constant c. Hence, that is 12 over here. But we want to write the 12 as a coordinate. You see, so we can say it simply implies that our y-intercept is 0. We know at the y-intercept, the x value is 0. So 0, 12. You see, on the other hand, if you want to actually solve for it, then you could say at y-intercept, what happens? Your x is equal to 0. Now if x is equal to 0, then we simply find f of 0. That is to say, we substitute the value of x into the function. So we have f of 0 being equal to 0 squared, that is x squared, then minus 8 times 0, that is from the 8x, and then plus 12. So with that, you have your 0 minus 0 plus 12, which gives us a 12. It simply means at x equals 0, f of x equals 12, which ends up giving you the same answer as we had over here. Now the second one, B, says we want the axis of symmetry. Now talking of the axis of symmetry, if you remember, we said it is that line that divides a function into two equal parts. you see, into symmetric part. And we said if we want that line, then we use a formula. And that formula is simply x is equal to negative b all over 2a. This is how we get to the axis of symmetry. So if you're able to know your formula, you are good to go. If we want our axis of symmetry, we know x is equal to negative b over 2a. And from our function, that is f of x is equal to x squared minus 8x and then plus 12. It simply implies that our a is always the coefficient of the x squared. So a, what number do we have in front of x squared here? It is what? 1. You see, we know if it is 1, it is not written. That was why it wasn't written. So our a is 1, and then our b is also the coefficient of x. In this case, it is negative 8. So negative 8. Take note, every coefficient moves with the sign in front of it, or in other words, it moves with its polarity. So you don't see the coefficient is just the 8, but then it is the negative 8. So from this, we substitute into the function, that is this equation here. We have x equals negative b. So negative, and the value of b is what? Negative 8. So negative b all over 2a, where a is also what? We said a was 1. So 2 times 1. The numerator gives us negative times negative, which gives us what? An 8. Then we have 2 times 1, which also gives us a 2. This, when evaluated, gives us a 4. It simply means that the axis of symmetry of this particular function is x equals 4. You see, so assuming this we have here was actually the function, then it would align somewhere around here. You see, so that we are just making an assumption. This isn't the exact function, but if this was, then it would have aligned somewhere around here, so that our axis of symmetry can be drawn through the line x equals 4. You see, this would have been its axis of symmetry. So assuming this was the function, even though this isn't, but I'm just using it for an illustration purpose. If this was it, then your axis of symmetry would have been this. You see, it passes through the line x equals 4. You see, that is just it. So let's look at the next question. The next question that follows says we should find the vertex. So finding the vertex, from our diagram, we said after finding your axis of symmetry, that particular coordinate of x gives you where you have your vertex. But to get it as a coordinate, we'll then have to trace it to where it touches the y-axis. And to do that, we put the value of x inside the function. So what do we mean by that? For the vertex, then it simply means for our f of x, which is equal to what? X squared minus 8x plus 12. Let's substitute what we have at the axis of symmetry. So let's substitute that so that we have f of 4. And f of 4 now gives us a 4 squared. That is, anywhere we see x, let's put what? 4 over there. So we have 4 squared minus 8 times 4 plus 12. Evaluating, we have 4 squared, that gives us a 16. Then 8 times 4, negative 8 times 4, we have a negative 32, and then plus a 12. Simplifying further, we have all of this, that gives us a negative 4. So it simply implies that the vertex is what? So x coordinate comes first. So we have 4, then negative 4. You see, as simple as that. Then, so this simply means if this was a function, it says 4, -4. So let's say it is going to be somewhere around here. You see, because this is the axis of symmetry, it is still the axis of symmetry, but then the vertex of it is on -4. It is somewhere around here. So you see, all these things we are solving for gives us a mental picture of what the graph or the parabola actually looks like. The last one says, does the parabola open up or down? Also in our lesson, we said the parabola opening up or down, that is it being a u or n, simply has to do with the value of a. You see, so if a is greater than 0, then we always have what? A u, in which case we have a minimum value. But then if a is less than 0, we have what? Something like an n, where that gives us a maximum value. So with that said, looking at what we have here, a is 1 and 1 is greater than 0. That simply means the graph is a u. It looks like u. So if we come back here, that informs us of how this graph is supposed to be. So it isn't supposed to be like this, but then it should be a u, something like this. And we had our axis of symmetry here, so it is going to be something like this. So initially we were guessing wrongly, you see, but then with the right information from all of these, the coefficients, and then the coefficient of x squared, that of x, and then c, you can guess what it looks like, you see. And now we are now guessing that it is actually a u, because a was greater than 0. And for greater than 0, then it always has a minimum value. This is its minimum value over here. So with that, we can conclude by saying, therefore, a is greater than 1. And since a is greater than 1, it is greater than, a is equal to 1. Sorry, a is equal to 1. And since a is equal to 1, it is greater than 0. And hence it opens upward. Very simple, isn't it? Okay. So now let's solve some few more examples as well. This one will have to do with the discriminant. So our next question we have here says what? Use the discriminant to determine the number of real roots for each quadratic. So our first one is x squared minus 6x plus 9. The second one is 2x squared minus 5x plus 1. Then we have x squared plus 2x plus 5. Let's start with the first one. So we have x squared minus 6x plus 9. Now we know how to get the discriminant. So the discriminant is simply b squared minus 4ac. Now when the discriminant is greater than 0, then we said it has two distinct roots. Now when the discriminant is equal to 0, then it has one repeated root. If our discriminant is less than 0, we said that one, it has no real root at all. So we can say complex root. With that, let's look at the first one. So looking at the first one, we have our a being equal to, a is the coefficient of x squared. So a is 1. Then our b is the coefficient of x, that is -6. Then our c is also equal to what? 9. So with that said, our discriminant is going to be obtained by simple substitution. B squared gives us a -6 all squared, then -4 times our a is 1, then times our c, which is also 9. -6 squared gives us a 36, so we have 36 Then negative 4 times 1 times 9 would also give us what? A negative 36. 36 minus 36 simply gives us a 0. So what is our conclusion? It is very obvious, isn't it? So it has just one real root. You see, so it simply implies that our first equation, x squared minus 6x plus 9, has one real root. So it has one real root. You could also say it has repeated roots. And that simply means what? The parabola touches the x-axis as I illustrated in the previous session. Very simple. Now for the second one, B, we have 2x squared minus 5x plus 1. So the same way, we have our A being 2, B being negative 5, and then our C. We need CS, so our C being equal to 1. So once again in our formula, our discriminant becomes B squared, which is 5. So 5 squared minus 4 times your A, which is 2, then times C, which is 1. Solving further, we have 5 squared, which gives us a 25. Then negative 4 times 2 gives us a negative 8. Negative 8 times 1, we have a negative 8. So with that, our discriminant will be equal to what? 17. And 17 is greater than 0. If our discriminant is greater than 0, we said it has two real roots. So for this particular function, that is 2x squared minus 5x plus 1, it has two real roots. You see? So that is it. That is, if you are to use either completing of squares, calculator, almighty formula, whatever method of factorization, you get x equals two numbers, two real numbers. Let's then look at the last one. So the last one was what? C. X squared plus 2x, then plus 5. We know our discriminant once again is b squared minus 4ac. So doing our necessary substitutions, we have a being equal to a 1, b which is equal to a 2, and then the c which is also equal to 5. And substituting, we have our discriminant which is equal to b squared. So we have 2 squared minus 4 times the value of a is 1, then the value of c is also 5. Simplifying, we have 2 squared, which gives us a 4. Then we have negative 4 times 1. That gives us a negative 4. Negative 4 times 5. That gives us a negative 20. So our discriminant is equal to a negative 16. That is 4 minus 20. This is less than 0. So what does it mean? It means our function x squared plus 2x plus 5 has no real roots. None at all. You see? So that is it for this. And it simply also means that the parabola does not cross the x-axis at all. So what then is our conclusion? We can conclude that for A, it has just one real root, B has got two real roots, and then C has 0 real roots. I do hope by now you are getting the concept and you are able to appreciate all that we are doing. Let's look at question number 3, which I will advise you pause and then try yourself before you come and then look at the suggested solution. Our third question here says, for f of x, which is equal to a negative 3x squared plus 12x minus 5, does it open up or down? That is the first question. Secondly, find the axis of symmetry. Then you find the vertex and then state the maximum or minimum value. This is a complete question on its own. Now this looks just as the first one we did. So you can pause and then try it on your own. So let's start with the first one. We know our function f of x to be equal to negative 3x squared plus 12x minus 5. Just by observation or comparing it to ax squared plus bx and then plus c, then we can simply say the value of a is negative 3. That is comparing the coefficient of x squared. The value of b, which is the coefficient of x, is 12. And then the value of c is negative 5. So with all these, a says, does it open up or down? So does it open up, this, or down? Now if we look at the value of our a, we said if a is greater than 0, then it will definitely what? Open up. But then if a is less than 0, it would open down. You see, that is where it will get a maximum value. So with that, we can simply conclude that what? Since a is equal to 3, is equal to negative 3, sorry, and the negative 3 itself is less than 0, then it simply implies that it opens downwards. Now the next one says we want the axis of symmetry. So we know the axis of symmetry, x, is given as a negative b over 2a. And we know what our values of a and then b are. So our x is equal to negative, the b was 12. So 12 over 2 times your a, which is what? Negative 3. We have x being equal to negative 12 over 2 times negative 3 gives us a negative 6. And hence our x is equal to a 2. You see, so it simply implies our axis of symmetry is the line x equals 2. It is the vertical line whose equation is what? X equals 2. We always know what we can use this for. We can use it to find for the vertex. You see, so that takes us to C, which says we should find the vertex. So for the vertex, we know we will always have to put the function, the x value, into the function. The function was negative 3x squared, then plus 12x minus 5. So for x equals 2, we have f of 2 being equal to a negative 3, then into brackets 2 squared, plus 12 into bracket your 2, then minus 5. 2 squared gives us a 4, so we have negative 3 times 4. Then 12 times 2 giving us a 24 minus 5. Negative 3 times 4 gives us a negative 12. So you have negative 12 plus 24 minus 5. Or you can say negative 12 plus 19. When you add that, you are going to get a 7. So it simply implies that the vertex of the function is simply what? 2. That is, x coordinate comes first, x being 2, and then y also being what? 7. That becomes the vertex of this function. Now the next one says we have to state the maximum or minimum value of the function. Now since it is a function that opens downwards, then it simply means we would actually be looking for its maximum value. You see, and the maximum value is where we have this vertex over here. So we say Since the parabola opens downwards, the vertex gives a maximum value. So the maximum value is simply what? 7. And it occurs at x being equal to 2. So in other words, you can say the maximum value of the function is what? 7, where x is equal to 2. As simple as that. That ends this third question. Now, if you are conversant with all of these, that is where algebra also sets in. So you can be examined on finding any of the values of the constants in your quadratic function. That is what question number 4 is going to test us on. So let's look at question number 4. So for this question we have here, it says find the value or values of k for which the quadratic 2x squared plus kx plus 8 equals 0 has one real root. It has just one real root. Remember, if a quadratic has one real root, then it is a double or a repeated root. Because for quadratic functions, so far as the highest degree is 2, then you are expecting 2 roots. But if you are being told that there is just one real root, then there's a repeated root. So we know for the root to be repeated, then the discriminant must be equal to 0. You remember that. So we say for repeated roots, then it simply implies that our discriminant, which is delta, that is b squared minus 4ac, should be equal to 0. From our function here, we have 2x squared plus kx plus 8. Now that is to say our a is equal to what? 2. Our b is equal to k, and then c is 8. That is a, b, and then c. So substituting into our delta, we have delta being equal to b squared. The value of b is k, so k squared minus 4a. A is what? 2. So times 2. Then c, which is also 8. And that should be equal to 0. Equal to 0 because we are saying equal roots. Or repeated roots, repeated roots. So simplifying, we have our k squared, then negative 2 times 2 gives us an 8, then 8 times 8 gives us a 64. So minus 64 is equal to what? 0. So making k squared a subject, we have our k squared being equal to what? A 64. Now we want the square root of both sides. So if you find the square root of both sides, we are going to get our k, which is equal to plus or minus 8. Now, these are the values of k. So we can say that k is equal to 8 or k is equal to negative 8. So therefore, k is equal to 8 or k is equal to negative 8. Now, it is best you test and see whether it works or not. So I'll leave that for you to do the testing and let me know in the comment section. But for now, they both satisfy. So the values of k are what? Either 8 or negative 8. And that is all. We've been talking of quadratic functions, but how do we apply quadratic functions in real life situations? With respect to that, we'll take our last question for this session. That is a word problem. So this last question says, a ball is thrown upward from ground level. Its height, that is in meters after t seconds, is what we have over here. So our first question says you have to find the time when the ball reaches its maximum height. Secondly, you have to find the maximum height. And then you have to find when the ball hits the ground. This is a very practical question that applies all that we've done so far. So for what we have here, it says its height h is a function of time, and it is equal to a negative 4.9 t squared, then plus 29.4 t. Now, the question you should ask yourself is this a quadratic? For quadratic, we know the function is given as ax squared plus bx and then plus c. So if you have to compare, you'd see the element with the squared over here. Hence our a is simply negative 4.9 and our b is also the 29.4, but it has got no c, it has got no constant thing, you see, so there is no c, or in other words, c is simply 0. So with that said, let's write down our a. So a is negative 4.9 and then the b is 29.4. So the first question was we have to find the time when the ball reaches its maximum height. Find the time. So since we want t, the maximum t, maximum. So if we were to come back to the graph, and instead of x, this here is the t, and then y becomes your h. Now this is the path of the stone. The stone is thrown upwards and it goes up and then gradually comes down. This is the highest peak, you see, and the corresponding time is what we have over here. Now, if this is the highest peak and this is the corresponding time, what do you think is this line over here? This line is simply the axis of symmetry, and we know how to get that, you see. So you see how we are applying the theoretical concepts to get our answer. So they are simply asking for the t's value at the axis of symmetry, which corresponds to where you have the highest peak. We know that is given by, so t is equal to, this time around is not x but then t. So t is equal to negative b over 2a. So doing our necessary substitution, we have our t being equal to negative, b was 29.4 all over 2a, where a is simply negative 4.9. If you are to simplify, you are going to get 4.9 dividing to 29.4 6 times. Then the 6 is divided by 2 to give us 3. So t is equal to 3. And 3 what? Remember, the t is in seconds. So 3 seconds. And that is just it. So the time the ball is thrown and then it reaches its maximum height is after 3 seconds. Now the second part of the question says you have to find that maximum height. So we know where, in terms of time, the maximum height is going to be, but we want the maximum height in question. So if this is our a, then for b, we want the maximum height. We know the height is a function of time. So if h of t is all that we have here, then we simply want h of 3, and that is going to be equal to negative 4.9 times your 3 squared. Since it's not going here, let's just go to the next page. So doing our substitution, we have h of t, where t is 3, is going to be equal to negative 4.9, then 3 squared. 3 squared is simply 9, so let's just put that there. Then plus 29.4 times 3. We are now to evaluate all of this. We have negative 4.9 times 9, which gives us a negative 44.1. Then plus 29.4 times 3 will give us an 88.2. This one evaluated gives us a 44.1. So the height after 3 seconds, which corresponds to the highest peak, the highest height, is simply 44.1 meters. That is how high the ball is going to reach. Our last question, it says, when does the ball hit the ground? When does the ball hit the ground? So if the ball is to hit the ground, it simply means the height is 0. And the height is what? H. So C, the ball hits the ground if H is equal to 0. So for H of t to be equal to 0, then it simply means we have what? Negative, so H of t was negative 4.9 t squared, then plus 29.4 t, and all this is equal to 0. So using a method of factorization, you can say t is equal to negative 4.9 t plus 29.4 is equal to 0. All I've done here is there is t squared here and then there's a t here, so I'm factorizing one of them out. So with that, we can equate t to be equal to 0. So t is equal to 0. That is at the start time. Then for this other one, we have negative 4.9 t plus 29.4 being equal to 0. If you solve trying to make the t the subject, you get your t, which is equal to what? 6. Kindly let me know in the comment section if you're able to do that. So all you do is you take one of this to the right hand side and divide both sides by the coefficient of t. Hence that t is equal to 6. So that is to say that it is after 6 seconds that the ball will hit the ground. See, very simple as you see. This video has been very long and I would end here so that you try these exercises on your own. So here are just 5 questions based on all that we've done so far. You just follow the same format. So you can pause the video at this point and then try on your own just to test your understanding. Please have your numbers so you learn maths the easy way. If this is your first time on this channel and you think it will be of help to you, you can choose to subscribe so that anytime I release a video, you'll be notified as well. See you in our next lesson and bye for now. Do stay safe.